In the autumn of 1899, a schoolteacher in a western Ohio crossroads filed a patent on a machine that threw manure wider than the wagon carrying it. He owned no factory. He had never manufactured anything. Not an engineer, not an industrialist. The Crossroads was Maria Stein. The company that would carry that patent for the next 100 years did not exist yet. Coldwater sat 10 miles west. It had nothing to do with any of this. Not yet. Our last film on this company opened in 1993, with a Georgia corporation buying a factory in Coldwater, Ohio. It said the plant at Coldwater began in 1971. A viewer who welded there corrected us. America built the farm. America tooled it. America lost the machine. We tell the stories of how that happened one brand at a time. Subscribe if you want to keep hearing them. This story begins not in Coldwater and not in a boardroom. It begins in Maria Stein, Ohio, in a settlement with a church, a convent, a store, and no rail line at all. Maria Stein, Ohio sits in Mercer County, in the flat agricultural plain along the state's western border, 8 miles from the Indiana line and 10 miles east of Coldwater. It was never a town in the legal sense. It was a crossroads. The families who settled it came north out of Cincinnati in the middle of the 19th century, German Catholic, and the settlements they left behind carry the names of the churches they built before they built anything else. They came with a specific idea about land. You did not sell it. You worked it, you improved it, and you handed it to a son who would do the same. That assumption shaped everything about how these farms operated, because a man who intends to hand a field to his grandson thinks differently about soil than a man who intends to sell it in 10 years. The farms were the reason the place existed, and the farms had a problem. Every livestock farm in America produced manure continuously and had to put it somewhere. Applied correctly, it was the most valuable fertility input a farmer had before commercial fertilizer became cheap. Nitrogen, phosphorus, potassium, produced on the farm at no cash cost, in quantities that scaled with the herd. Applied incorrectly, it was a liability. Piled where it leached, spread where it burned the crop, or forked by hand at a labor cost that made the whole exercise marginal against simply letting the ground rest. Manure spreaders already existed by the 1890s. Several companies built them, and the mechanism was settled. A wagon box on wheels, a moving floor called an apron that dragged the load rearward, a rotating beater at the back that broke the mass apart and threw it out behind the machine. The machines worked. But they carried a flaw the entire industry accepted because nobody had solved it, and it was not obvious that it could be solved. They spread the load in a band about as wide as the machine itself. A spreader with a 5-foot box laid down a 5-foot strip, which meant a farmer covering a field drove overlapping passes spaced close enough that he was working the same ground twice, and the material came out heavy and concentrated in that narrow band instead of thin, and even across the surface. The agronomic consequence was visible from the road. Concentrated manure in a strip does not feed a crop evenly. It produces streaking, uneven emergence, and in heavy applications, it burns seedlings outright. You could stand at a fence line in July and read the previous autumn's spreading pattern in the corn. Dark green where the material had landed, pale and short between the strips. A record of the machine's limitations, written across 40 acres, every season for as long as anybody could remember. The labor consequence was worse. Covering 100 acres at a 5-foot working width is an enormous number of passes. Every one of them costs a team, a driver, and daylight, in a season where daylight is the binding constraint. Understand what that meant on a Mercer County farm in 1895. A farmer with a dairy herd and 160 acres generated manure every day of the year and had a window of a few weeks in spring and a few weeks in fall to get it onto the ground. The rest of the year the window was closed. Frozen ground would not take it. Growing crops were in the way. Wet ground would rut under a loaded wagon and cost him more in compaction than he gained in fertility. So the material accumulated for 10 months and had to move in two. The math did not work, so most of it never reached the ground. It went into a pile, and the pile leached, and the fertility the farm had produced at no cost drained into a ditch. Every manufacturer in the business was competing on capacity, on durability, and on price. On how much the box held, how long the chain lasted, what the machine cost. Nobody was competing on where the material landed. That is worth sitting with. 4 or 5 established manufacturers, all of them with engineering departments, all of them building the same machine, and not one of them treating distribution width as a design problem. It was not a failure of capability. It was a failure of framing. They were building a hauling machine that happened to discharge at the back. Nobody had reframed it as a distribution machine that happened to haul. Joseph Oppenheim taught school in Maria Stein. He was not an engineer. He held no manufacturing background, no prior patents, and no capital worth speaking of. What he had was position. A rural schoolteacher in an agricultural settlement in 1895 lived inside the problem without owning it. He walked past the same fields every day on the way to the schoolhouse. He knew which farms had streaked corn and which did not. He was close enough to see the failure clearly and far enough outside the equipment industry that he was not carrying its assumptions. Consider also what a rural teacher's year actually looked like. School ran on the agricultural calendar, which meant the schoolhouse emptied when the fields needed hands. His free time arrived in exactly the seasons when spreading was happening, and his winters were long, indoor, and quiet. A man with a mechanical question and 4 months of Ohio winter has a workshop whether he owns one or not. The question he worked on was narrower than build a better spreader. It was this: how do you make a machine throw material wider than the machine itself? That sounds like a refinement. It was not. It was the difference between a device that saved a farmer some forking and a device that changed the arithmetic of the entire operation. Run the numbers the way a farmer would have. If a spreader lays material across a swath meaningfully wider than its own wheelbase, 3 things happen at once. The farmer covers more ground per pass, so the pass count per field falls. The load goes further, so a given quantity of manure treats more acres. And the application comes out thinner and more even, so it feeds the crop instead of streaking it. 1 mechanical change. 3 economic effects, and they compound. The established manufacturers had every resource Oppenheim lacked: foundries, patent attorneys, engineering staff, national dealer networks. What they did not have was a reason to question the shape of the machine, because the machine was selling. Oppenheim had no such constraint. He was not defending a product line. He was looking at a field. That is the whole asymmetry, and it recurs across almost every story on this channel. The incumbent optimizes the thing. The outsider asks whether it is the right thing. Oppenheim's solution sat at the rear of the machine. A distributing mechanism that took material coming off the beater and threw it laterally, out past the wheels, to both sides. The material left the beater with momentum it already had. The distributor's job was to redirect that momentum outward instead of letting it fall, which is why the solution worked without adding a separate drive, a separate power source, or meaningful weight to a machine already at the limit of what a team could pull. That constraint matters more than it sounds. Any solution that required more horsepower was dead on arrival, because the horsepower was a team of horses and you could not simply add another pair to a machine already sized for 2. The answer had to be free. It had to take energy the machine was already producing and point it somewhere more useful. He worked on it over years, not months, and he was doing it in his own time, in a settlement with no machine shop worth the name. And this is where the company's name comes from, which has confused people for more than a century, because it reads like a slogan. It was not a slogan. It was a description. The machine was a new idea, a specific, patentable mechanical proposition about where manure should land. The company took its name directly from the product, and then carried that name for 100 years while selling machines that had nothing to do with spreading manure at all. A patent is not a company. What happened between the drawing and the first machine delivered to a farm is the thinnest part of the surviving record. A company was organized in Maria Stein to build the machine under the name New Idea Spreader Company. And then the location started working against it. Maria Stein had no industrial infrastructure. It had limited labor beyond the farm families already working the ground, and it had no rail. A manure spreader is a heavy, bulky, low-value per-pound object, a wagon box on wheels with iron mechanism inside it. You cannot ship that economically by road in 1905. You ship it by rail, or you sell it to whoever can drive a team to your shop and haul it home. And the second option caps your entire company at a radius of about 20 miles. So the company had a machine that answered a problem every livestock farmer in the United States had, and a location that could only reach a few hundred of them. Selling it had its own problem. You cannot describe a wider spreading pattern to a farmer and expect him to believe you. Every equipment salesman in Ohio was making claims. The only argument that worked was the machine itself, running, in his field, throwing material out past its own wheels while he watched. So that is how it was sold. County fairs. Field demonstrations? A loaded spreader, a team, and a strip of ground, with neighbors standing along the fence line doing the arithmetic in their heads. That method built loyalty that advertising could not. A man who watched the machine work and then bought it did not just own a spreader. He had made a public judgment in front of people he would see every Sunday for the rest of his life. Everything in the following decade is that contradiction resolving, and it resolved slowly. A company with a patent and no capital does not relocate on a decision. It relocates when the order book has outrun the shop floor for long enough that the cost of staying finally exceeds the cost of moving. Production expanded. The dealer network pushed outward from Mercer County into the surrounding counties, and then across the Indiana line. And the plant at Maria Stein reached the ceiling of what the site could support. The company had two options: build rail to the Crossroads, or move the operation to the rail. Coldwater sat 10 miles west. It had rail, it had room to build, it had a population large enough to staff a factory instead of a shop. In the years before the First World War, the company moved. That is the sequence. Invention at Maria Stein, company at Maria Stein, moved to Coldwater only once the machine had outgrown the place that produced it. The plant we said began in 1971 had by then already been running for 2 generations. So what was the machine? A box on wheels, wood-sided, sized to what a team could pull with a full load, and built to be filled by hand with a fork. The floor of that box was not fixed. It was an apron, a slatted conveyor running on chain, driven off the ground wheels, so the feed rate was tied directly to travel speed. That detail is more elegant than it sounds, because the drive came from the wheels. The machine could not over-apply if the team slowed down and could not under-apply if they sped up. The application rate stayed tied to ground covered, not to time elapsed. A modern engineer would call that ground speed proportional metering and charge extra for it. In 1899, it was simply the cheapest way to build the thing. As the machine moved forward, the apron dragged the load rearward at a rate the operator selected. That selection was the application rate. Faster apron, heavier application. Slower apron, lighter. There was no metering system beyond that. There did not need to be. At the rear, the beater. Its job was to take a compacted, frozen, or matted mass coming off the end of the apron and reduce it to something that could be thrown rather than dropped. Everything downstream depends on that. A distributor cannot spread a clod. The beater is also where the machine earns or loses its reputation in February. Manure that has sat in a barnyard through a Mercer County winter does not arrive as a uniform material. It arrives frozen in sheets, matted with bedding straw, bound together in a way that will stop an underbuilt machine on the spot. If your family worked at Maria Stein or Coldwater, or you hold literature, photographs, or a cereal plate from before 1971, put it in the comments. We got this one wrong the first time because we did not ask you first. See you in the next one.